vários artigos premiados, e uma pessoa super bacana, nós acabamos fazendo uma amizade, depois de décadas de trabalho em conjunto. É uma felicidade ter o Patrick aqui e falando hoje sobre esse tema, ciência de dados e inovação. Obrigada, Patrick.
Bem-vindo. Vou falar em inglês, senão é mais rápido. Let's switch to English. I hope people in Brazil speak very good English. I'm going to talk about two difficult topics: data science, not too much because I hope you know from the outside what it is, and innovation. I will cut some slides towards the end because I don't think we'll have time. I'd like to leave maybe 10 minutes for discussion because it's usually a topic that people like to comment and discuss. So the reason, well, first of all, the motivation for the talk is that there's what I call a virtuous cycle. So you all know what is in data science. It started with big data. And then you need to analyze the data, we call it analytics, and we use machine learning, information retrieval, statistics, which is much older, but which is very, very important in this context. Then, why is data science? Because many people consider it's not really a new science, everything was there, but it really addresses real challenges. And the challenges come from data-intensive application, which basically means all kinds of applications today. It started with the web, because the web giants had the problem to analyze the data, but you have the problem in science in general, astronomy, geology, and so on, health, energy, etc. So this provides requirements for data science, where people do research, and what the research does is that it produces innovation. It's supposed to produce innovation, basically meaning technology, big data, databases, search workflow, Spark, etc. And in terms, this technology, when it is good, has impact on the application, makes the applications better. And as the application gets better, it requires more data, no wonder why, so or more computing power. For example, Alvaro will tell you that with HPC, the bigger the machine is, the better, because they always want to understand bigger phenomena and so on. So the nice thing about it is that there's no escape out of this cycle. You know, it's gonna and it's, of course, I'm not going to comment on this, but it's changing the way everybody lives in this world. Right? So the outline of this talk, I'm going to focus on and give definitions, because I find this trouble of writing books is that you always find a lot of confusion, because when you write a book, you need clear definitions. And I've written several books, and I will show you that you need good definitions. There are good definitions, but the way people use the terms innovation versus invention is very confusing. So I will make everything clear, focusing on the technology part. Give you some example of success stories in data science in general. Very quickly about what we are doing as a result of everything that Marta mentioned. We have been working for like 25 years together, and the result is a big partnership between Inria and Brazil, which is called Inria-Brasil. There's a website, Inria-Brasil, and I will tell you that Inria-Brasil not only does research, which I would call business as usual for researchers, but also innovation, which is hard, much harder. And then I will conclude. So let's talk about innovation first. So what is innovation? It's like a Wikipedia definition. So innovation is producing something new to the world in general. So in economy, it can be a new process, a new product, a new business model, Uber. And to society, in the old times, we're talking about innovation of ideas, belief, religion, political systems, and so on. When people talk about innovation, in companies, in universities and so on, there is an implicit assumption that innovation is good. And that's not true. It may yield progress, of course, but it may not. And you're young people, so you're going to build a new world. And so you have to be careful about that. It can be sometimes harmful. It's an old story. You know, in the 16th century, in England, there was something called the innovation ban. Innovation was banned by law. If you were supposed to do innovation, it was a different story. It was during the Protestant Reformation. Everybody had new ideas and so on, and it was very hard to rule the country, and you could be sentenced to death. So you could say, well, today you're not as cool or stupid and so on. Well, you know, this is 2 weeks ago. This is later against AI, right? AI is innovation. It can harm as well, okay? So I'm not going to discuss whether it's good or bad, but just know that it's not always good, right? We think of innovation. Okay, now let us focus on technological innovation, which is one subset of innovation. So the definition is simple. It's new technology, which usually comes as a result of research or R&D in companies and so on. So for example, a new technology might be a new piece of code that you implement, a code library. And the research result is a new algorithm. Okay, algorithm is a more mathematical thing, and the code is the artifact. So in companies, people are discussing technological tech and innovation. I've been in many meetings, and my feeling is that there are really two ways to look at it. Usually within a big company, big organization, because you know the market and the customer base, otherwise you're out of business. You could have a formal process, which is a company strategy, and it's a top-down process, right? And then we talk about managers. I will go into more details about what I mean by manager. Within a new company, a startup, for example, typically the context is quite unknown, right? And in fact, when you do a startup, you barely know what you're going to do. You have some ideas. And since it keeps changing, you cannot have a formal process. It's very hard to formalize. Then we talk about leaders. So you might want to ask me, what's the difference? Leader, manager, this is really the same thing? Not really. Well, of course, there are common features because our people will manage people. So they should be, they should not be stupid. Well, sometimes you have managers and leaders who are stupid, but that's another story. So they should have knowledge, experience, dynamism, etc. But my feeling is, and I discussed this into this article in the Sigma journal, a manager is more in a big company, he's in charge of implementing the company strategy, right? So he may come out of a management school and may lack technical skills. So for example, in France, we have like 250 engineering schools, but we have about 200, I was surprised by the number, 200 management schools, which means you have, for every engineer you could have, it doesn't work like this, but one manager. It doesn't work this way today, right? And why it may be a problem is that when the manager, he's a big manager, he knows very high-level things, but at some point you need to communicate with technical people. And today, everything is run by technology, you know, computers, machine learning, whatever. So you may end up with managers who are not able to communicate with the techies. and this makes life very difficult. A leader is someone who is able to create a vision for a team and may come out of the team and move the team towards a common goal. So usually has very strong technical skills. And in the world that I'm living in, researchers, and we have a lot of engineers in IT, that's the only way to be respected, right? Because if you don't know what you're talking about, people will say, sure. So this is very important, and usually the best leaders are the leaders who come out of a group of people and recognized by the people. Let me give you a story. I like stories. Not the one that I gave last time at the workshop, which is a good one, but which is there. There's a story here, which is a real story. But I'm not going to explain this one. So the story is that there's a guy who enters a bird shop. He wants to buy a bird. And it's full of parrots, papagayos. And they are ranked by price, from the cheapest one to the more expensive one. And you can see some progression in terms of color, etc. And at some point they are quite similar, and the customer asks, but what's the difference between these two? This one is much more expensive, and the answer might be, well, this one speaks 20 words, whereas the other one only 3 words. What about this one? Oh, this one speaks 2 languages instead of 1. Up to the end, where you see the most expensive bird, and it's an old bird, ugly, doesn't look in good shape, and the customer says, "Oh, this one must speak many languages, must be very intelligent," and the owner said, "No, what not? No, it doesn't speak. So how come can it be so expensive?" And you say, "Well, I don't know. All the others call him leader." So it's something which is obvious. Well, just to tell me that you can have a manager who is a leader, right? Bill Gates was probably one of those. He was able to give a keynote talk at SIGMOD, which is a tough database conference, and answer technical questions from people like me, people like professors, and so on, which is not always the case. Okay, technical innovation process. Well, the first thing you need if you want to invent this thing which has some impact, right? Which we use, it's everywhere. It's so obvious that we forget about it. Right? But there was a time before that, right? Where there was no problems. You need invention. So invention is, for example, new methods, new techniques, whatever. But that's not enough, right? Why, if you invent the bubble, but electricity doesn't exist? It's not going to work, right? So you need a context, and you need also the users to adapt to the context and so on, and also you need the good timing. So there are 3 aspects which will turn the invention into innovation. Right? So let me discuss the difference between the 2, which seem to be obvious, but it's going to be more subtle. So an invention is a new thing, like a new method, like algebra was an invention, a new process, the printing, which became the printing industry, or a machine, a smartphone. And it can combine several inventions. The smartphone is a bunch of inventions together, right? It's a computer, it's a mobile phone, it's development environment, etc. So these are inventions. And an innovation is an invention, of course, but that has impact, meaning that will change something in the user behavior or the business. So it's very hard. Only a few inventions lead to innovation. It's not because you have an invention that you will do innovation. In fact, many inventions are completely unknown. It can be accidental. I like the story of the pacemaker. I don't know if you know it, but the guy who did the pacemaker didn't want to do a pacemaker. He wanted to do a device that would imitate the heart for his study, but it did a wrong circuit, wrong transistor or whatever, and it started to behave like a pacemaker. So, which means this is a very good news. It means that it's better to do something even if it's wrong than nothing, because even if it's wrong, it could be useful to do something else. Right? It can take a lot of time. For example, the airplane. Well, there's big debate about who did the airplane, who invented it. So since you are in Brazil, I'm sure you have an answer. Who did it? So, Santos Dumont. Yeah. If I were American, I would say the Wright brothers. And if I was Italian, I would say Leonardo da Vinci, because he invented something which looks like an airplane with 200 drawings, and that was a long time ago. And I think this was the invention, but the world was not ready, 16th century, and the technology was not there yet. Okay, so you need to. So it's very complicated. You need to be at the right time, and maybe at the right place as well. Okay. And there is a relation, an important relation between the two, right? Because there's this issue of documenting and protecting and leveraging invention so that you create more innovation. So the typical solutions are patents and public licenses. I'm not going to enter in the polemical debate because there's often, in software in particular, this debate between proprietary software versus open software. But what we can say is that the solution should depend on the particular situation. There are cases where patents are good, there are cases where public licenses are good. And the two solutions are usually, they might be compatible. So you may have a public software with parts. This is the case with Eclipse, for example, where some components may be proprietary. So, but usually they are exclusive. So a few words about patents. So you have to remember that patents are really recent, because before patents, what the inventions were like trade secrets. Like, for example, the recipe of Coca-Cola. There's no patent. It's a secret. Nobody knows. So, which makes it very hard to imitate. So patents give legal protection of IP to the inventor, but there's also documentation so that others can read it. It's like a research paper, and you can improve them. So I did some work with a professor of history of computer science with people at MIT some time ago about patents, because at that time there was a big debate in software patents where many people would say that patents were usually stupid, there was nothing and so on. So we say, well, let's look at the data to see what's happening. We came up with a subset of patents, 50. And we found out that, and it was very important, that the heavily cited patents, like the heavily cited papers, they yield innovation and they have a lot of impact. But many others that were not cited didn't have impact, didn't yield innovation. Innovation and impact are very close words. So let me give you, this was not in the sample because it's so stupid, but an extreme patent, which means that you can do, this is a patent from the US patent system. So as you understand, no speak. You know what is no speaking? That's what the children do. Some adults do as well, but usually it's another story. So this guy did a one-page patent. It's very small, right? This is a patent. And this is there's a few other drawings, but basically that's it. So which means you can do patents with everything, right? So because I've seen people, in meetings where they're talking about innovation, and one will say, "Well, I've written 10 patents." Sure, can you show me your patents? Right? Because if you've written 200 patents like this, you're not going to be impressive, right? But at the other extreme, this is the magnetic core memory patent, 1956. It's different story, very technical. It's a way to store information in a computer. It was a revolution at that time. It was done by MIT scientists. It's a 10-page paper, very technical. So it's like a research paper, but in research paper we have a lot of noise, introduction, related work, and so on. The patent just says, here's the solution, right? And describe, for example, the algorithm. Here's the algorithm. And then you don't bother doing the state of the art because the patent officer will do it. The job of the patent officer, when the patent is granted, is to say it's original, right? Meaning that the patent officer has checked all the state of the art, which is something difficult to do. So this project was done in the context of a new computer project to do real-time aircraft tracking. It was the first application at that time of real-time data processing. And well, basically the main idea is to store, because at that time the technology was very basic, and it was a very clever way of storing the information in 3 dimensions. It had a lot of impact. There were 9 other patents which also had impact, and that technology was used during 20 years by all single computers sold in the world, which means that MIT, which was the owner, and maybe the scientists, because usually the scientists get a portion of it, received a lot of money from IBM and all the big companies, because at that time the royalty were based on the price that was to the customers, and the machines at that time were much more expensive than this machine here. So that was a big success. Okay, the typical critique of patents. So on the positive side, they protect inventors' rights, they encourage invention, investment, and return of interest. A lot of companies, they buy other companies because of the patents. But they may hurt innovation because, well, the average in Brazil is the same patent term is 20 years, which means you get the exclusivity of the monopoly for 20 years. So this may hurt competition, of course. You may have monopoly situations. And it may hurt collaboration with academia, and today it's very important. Companies, they have to innovate with academia, because in academia, of course, we need to publish or perish. This is the rule. Well, not everywhere, but and patenting takes time, and you cannot write the paper before the patent. It's the other way around. Right? So patent always comes. The paper always comes next. So the alternative, which is usually no patent, is to have public licenses. So here the idea is different. The idea is not to protect the invention. The invention is not protected, in fact. It's to protect the artifact. And this is why there is often a confusion between patents and public licenses. We are not talking about the same thing. So the artifact can be open source software. We are talking about open source hardware today. We are talking about open data, open everything, open genome. Well, the invention is usually described in research papers. And in fact, being in a research paper gives you some protection, right? Because there's copyright. But it can be simply white papers. So the license specifies how the artifact can be used. And this is where it gets complicated because there are different licenses and different constraints. So for example, what's called copyleft licenses, as opposed to copyright, it's wordplay, like GPL, or the equivalent in France, Cecile, or in Europe, they are viral, meaning that if you develop a piece of code using a GPL code, your code becomes GPL. If your code is GPL, it is public. You cannot hide it. If you hide it, it's illegal, right? You can be sued by, for example, the Free Software Foundation has lawyers and so on. So it works, but so for example, Linux is GPL. With copyleft is a little bit more tolerant. It's useful for code libraries, and you have very permissive licenses where you can do basically whatever you want. You just need to cite the source. So this has been the basis for many successful projects, starting with Linux, Apache, PostgreSQL, and today machine learning tools, and some which are done by big companies. And why do they use open source software? Because there is the innovation comes by sharing. You know, today we know that doing something very complex cannot be done by a single group of people or by one person. Nothing more. So you need collaboration at the international level. And so, for example, a company like Google, although it has really strong people, benefits of the collaborations of many other people. Scikit-learn is the equivalent of Inria, and in fact, I just learned that they want to do a startup to do business around it. So for a long time, people were telling me that you couldn't do business with open source software. I never understood this, because you can do business with basically everything today. Of course, you don't sell something which is open source, because usually it's free, but you can sell services. And what people want today is services, right? Because if you ask your grandmother to download Linux and to install Linux, it's free. She will have a hard time. Well, maybe not. Maybe your grandmother is a hacker. I just saw a movie where the guy enters a place to see a hacker solve the problem. He's ready to see someone like this guy, you know, in shorts, beard, and it's a grandmother. So just. But anyway, and because of the cloud, which is really service-oriented, you know, in the cloud, what people want is to use services. Well, open source really made it big. Like, for example, IBM got paid that for $10+ billion, and Microsoft's same thing with GitHub. So it has a lot of impact, right? Okay, some success stories from data science. So data science, when I was not here, I was in Paris at the time, but similar, it was a bit bigger place with 200 students. We were talking about databases at that time, but today we would say data science. So we start with databases, and you all know about Oracle, right? It's the #1 company in data services in the world. But in the 80s, they started in the 80s, after a few years of R&D. It was a time of relational databases. And it was a good time, because there was a mathematical model, very simple by mathematician code, 1970. It took 5 years for the researchers at University of Berkeley, at IBM. IBM was very big in research at that time, to understand the potential. 5 years, 10-page paper, because nobody understood. And then some people at Berkeley, Michael Stonemaker, some people at IBM, understood, oh yes, you can do something. So they build products, they build projects. So for example, System R, they invented the SQL language. And then Oracle, which came out of people escaping from IBM because they saw the business potential, they came up with Oracle 2.0, first version, 2.0. 1.0 never existed. And in fact, if you look at innovations at that time, almost none. They just implemented the SQL language. In fact, I know it very well because I was a PhD student at that time, and I did a survey of all the relational products. There were about 10 products, but many products didn't even have a query language, so you had to write programs. And so the only one which was good with SQL was Oracle, but that was the only one that I could not go to the end because it was full of bugs and it was not really working. Because in fact they used the techniques which were published in all the Ingress or Systema papers. But they were lucky. So that's the part that I didn't mention, but when you want to do innovation, there's one part that you cannot control, which is luck. You know, some people are lucky, some people are not lucky. And they were lucky because IBM had a product, but IBM had this strategy of proprietary mainframe, etc. So IBM was working only for the mainframes. So Oracle tried to have a version for IBM computers. It didn't really work because it was incompatible with IBM. Because IBM had the strategy of keeping all its error code secret. So it was the opposite of open source, for example. But at that time, Oracle was very lucky because started the Unix-based operating systems, which were an alternative to proprietary systems. So this was the beginning of Oracle. Almost no innovation, but a lot of luck. But of course, later on, they had many, many innovations that I will not cite. There's one that I like very much because Valduriez was one of my PhD students on parallel query processing. I was coming back from the US, I used to work on that, and he went to Oracle after the thesis to build Oracle Parallel Server, which is one very important product. Let's get back to PostgreSQL, because PostgreSQL was a successor of Ingress at Berkeley. So that was the next generation of relational database. And it was really the first open source relational database after all the Linux and so on. It has very strong innovation, abstract data types, rule-based programming. I'm not going to explain what it is. I'm sure you will have your professors here explaining, but it had, until today, it started a long time ago, 85, and today it is the fourth most popular database engine out of 300 other products. So it is very successful, and it yields a lot of money to companies that do other products like Aster Data, which is Postgres variation for analytics, or CPUSDB, which has been bought by Microsoft for the cloud, etc. Par excellence as well is a parallel implementation of PostgreSQL. More recently, and this is really also strong innovation. So remember Valduriez, so he's the CEO and founder of Snowflake. Snowflake is the last and probably highest success story in history at the NASDAQ. The company was created in 10 years ago, and it did the largest IPO at NASDAQ 3 years ago, which valued the company something like $30 billion. So Valduriez is a big billionaire today. You can look at his webpage where he talks about me. So what's very interesting here is that there are competitors. It's basically data warehouse in the cloud. So everybody needs data warehousing technology, but it's usually very expensive. You need to go to Oracle, to IBM, to Microsoft. Whereas in their case, you can have it on Amazon, Azure, Google, whatever. and it's very easy to use, very easy to install. So small companies, medium-sized companies, they can do data warehouse. And there are many innovations, like all the, in this architecture, all the levels are independent. So you can do separate provisioning, which is very important in the cloud computing, invoicing, and so on. So, for example, if you have lots of data, you can have many more virtual machines to store the data, or you can have virtual data warehouse to parallelize the big queries, and so on. And the last one is lean scale. So today, although I'm retired from Inria, I'm chief scientific officer at lean scale, which is a new company doing a new SQL database. So it was created by a friend of mine, Ricardo Jimenez-Peris, who is based in Madrid. And the nice thing is that he was very famous as a professor and a researcher in transaction processing. And in my case, it's more query processing. I mean, if you ask an expert what's hard with a database in order to build it, well, transaction management and query processing. These are the most two complex things to do. So we have been able to introduce many innovations, which come, in fact, out of this book that I'm co-author of with Professor Ozu from the University of Waterloo. And there are many innovations. And we also do, of course, patents, but papers. So, for example, everything which has to do with ultra-scalable transaction processing or elastic and scalable processing has been published last year in 40-page paper. It's a pretty big paper, it's a big journal. So it shows that innovation is really at the heart of this company. It has many other things that I don't have time to talk. A few words, maybe 5 minutes and we're done, so we can talk about Inria-Brasil. So I have several projects. People say, well, now that you're retired, you can do so many things. So I'm spending a lot of time on this. We did a workshop 2 weeks ago, 2 days in São Paulo, 3 days in Petrópolis at LNCC. So formally, it's a contract, partnership between Inria, which is a research organization in France, LNCC, which is a research organization in Brazil. But it's not only with LNCC. It's beyond, and beyond meaning all the big universities that want to work or already work with us. FRJ, USP, PUC. So we have about 12 universities. We can have more. And we build this partnership bottom up. It's not top down. I don't like top down. Maybe you understood, because top down is very easy. Well, it's very easy to start, You have someone who has power, money, and says, we'll do this. And then it goes down, and then you have people who need to do the work. In research, it doesn't work. So we did the other way around. We looked at what was going on between French and Brazilian researchers. We looked at what worked, and we found out that we are very good in HPC, AI, scientific computing, and data science. So that's the goal. So we don't want to do everything, right? Robotics, whatever, which is very important. But we want to be focused. And the reason we want to be focused is we want to have innovation. We want to do research, of course, inventions, but that's not enough. Because Inria and same for LNCC, we get money from the Ministry of Industry, so we are also supposed to help our countries to create jobs for people like you and so on. Not just publish papers for other countries to look at and do the technology. I'm thinking about countries much farther than here that are very good at that. Okay, and we address, remember the virtual cycle, the challenges of scientific and industrial applications. So we work with industrial partners. At the workshop, there were companies like in São Paulo, there was Stellantis, a big company behind Peugeot, Citroën, etc., doing very well actually. And in Rio, Valduriez, Total, Orange, and some others that I forgot. So just one example of a very successful project we did with Alvaro, Marta, etc. was a project between Brazil and Europe, funded by the European Commission. So there were companies and universities. So as you can see, Valduriez, IBM Brazil, Repsol, Total, and we're focused on energy applications, and there were a lot of results, including transfer to industrial partners. So this is one. I'm not going to detail, but basically the technology which has been produced is used by these companies. This one I will slow down because it was done here with Inria and IBM Brazil. So in the context of computer science and engineering, this is problem of data science paper, problem is very often to analyze the data, but to do something useful with the data, not too late. And the problem is that the data can be very heterogeneous, coming from various workflows and so on, hard to integrate. So the answer to that problem was PESC-COPPE, which is a data management system. Very clever. There's an open source, there's an artifact on GitHub. The key person was a PhD student who was advised on Marta at this university and myself, who got a nice PhD award at the national conference. Extremely good papers and impact. The software is used by other teams in the world because it's open source. So, for example, this is a recent survey paper that says very nice things about PESC-COPPE. Although the focus of the paper is machine learning life cycle, but they say that PESC-COPPE, which was not done for this particular topic, is still very useful. And it's also used by IBM, especially in Brazil with their clients. This I will not talk about. This is a very cool application in my team, PlantNet, for plant identification. But very quickly, we did some optimization with a PhD student from Brazil. And we are working with LNCC using something called the Gypsy framework. It's really based on machine learning, right? It's a big success, and maybe some of you have it on your smartphone. And we are starting a new project with CIRAD, which is in France, and Ushti, to understand the Amazonia flora, which is much harder than the flora in Europe. In Europe, you can go wherever you want and hike and take photos. In Amazonia, it's a bit more complicated. Right? So we are starting a project there, and a project with I don't know if Daniel is still here. Daniel?
He's on YouTube.
Okay, so Daniel was there at lunch from UFI. So there was some work. We have another in France very interesting project called OpenArea, which is used for plant phenotyping and so on by various organizations. And the problem was to improve the performance, and the solution was to use adaptive caching. There were good papers, including the best paper award, and this is now implemented and used by the organizations that are users of OpenArea. Okay, so I'm pretty good on time, so just, well, let's focus on this because I'm very interested in making it, it's already a success story, but since we formally signed the agreement between the MCTI in Brazil, or representative, and representative of Inria 2 weeks ago, for 5 years, I'm going to work on this and hopefully get help by many people here. So what well, obviously we do have success stories. So this is very important because if we wouldn't have success stories, I'm not sure I would be involved too much. You know, I've known so many colleagues who started things and said, we'll do this, we'll do that. And 2 years later, they would do something else. And well, we have already demonstrated that we can do successfully, but there is room for more. So the goals are to do, of course, inventions, meaning high-quality research. It's a very competitive environment. We want to create an environment with companies from France and Brazil who work with us to implement this virtual cycle. And of course, we want to get money, but what I mean is sustained support. We don't want to have what I call, and many countries or organizations, funding agencies are good at that, which I call one-shot funding. So have a lot of money, they do a huge project, and then 2 years later, nothing. It doesn't work like this. For example, the collaboration between France and Inria-Brasil has been going on for 20 years because you create an ecosystem, and the ecosystem needs to be living. So that's really what we. I hope I convince the people there at the workshop that if they start funding now because they are very happy, they sign, they had some good drinks and so on, and in 2 years they don't give funding, then I will be going after there and tell them, well, you agreed about that 2 years ago. So, well, but usually this is politics. They will be gone, and the new people will say, well, but I was not there. Okay, it's always here the one sport. But that's very important because timing is important, as I tried to explain in terms of innovation. If you want to have positive impact with the innovation, because you can have also negative impact on the innovation. Thank you very much. We have time for questions.
Yeah, Patrick, can you come back 2 slides when you say the HPC AI? Yes, no, one more. Yeah, it's important for you guys, the students, that you're going to learn in this course HPC, AI, machine learning, data scientist, computing, and data science. In the beginning, they appear as different fields, but they are converging much quickly. And I think what Patrick's point here is trying to make you aware that those things are converging. Right? Can you comment, please?
Yeah, in fact, this was one of the best thing I learned working with you guys, because my teammate was Marta, so basically same background, right? Distributed database, parallel databases, so we can understand each other. And then we started to talk with Alvaro, and it was, so we are here, and he was here, and here. And then it was a different story, and we learned how to work together. And I remember, right, we had talks on simulation and data science or big data and whatever. And because everything is so complicated today that you have separate fields. And when you are able to put them together, and you need a team, you need people who are able to understand each other, and you get a lot of leverage. In fact, if you read the short article that I, how to turn into a kind of senior researcher, I talk about that of course, if you do a PhD and a postdoc, you're an expert. You've done something. But then when you want to, when I was in the US, I was a fresh PhD, 2 years after my PhD. My first performance review, which I explained in the article, because you have, so in the US, every year you have a performance review. This is very important because if it's bad, you get no bonus and you may be fired. And if it's good, you get a big bonus. And my boss told me, you're a good woodcutter, meaning that you can take a tree or a problem and cut it in the best way. But so he says that's very good. That's what PhD students do and junior researchers. But if you want now to move to the ladder, you need to look at the whole forest. And that's much more complicated because you need to work with people who didn't do the same thing as you do. So for example, you're from data science and you start working with people from HPC. These people from HPC or scientific computing, they know much more. In fact, I was completely lost at the beginning when I saw all the equations that, for example, Alvaro would put. So you need to be very humble, right? You know things, but you don't know everything, right? And it's very good for your ego, you know? So that you can say, oh yeah, I can learn a lot from this guy, from these people. So there's, of course, you need to mix all these, but it's very hard because typically, because of history, data science is done there. Well, even data science is very hard. You know, what's happening, for example, is that you have computer science where you learn databases and so on, and you have statistics is very important. It's not in the computer science, it's in France, it's in the mathematics, right? And usually talking between mathematicians and computer scientists is also another story. So all this is very hard, but this is how you can come up with some unity and solve real problems, because in practice you need to combine this. Well, that was a long answer, but it shows that if there's one thing that when people told me, what did you learn working with people in Brazil? There are many things that I learned, but that one was really good.
Patrick, I'll ask you, but perhaps Alvaro can give also an answer.
Sure.
Perhaps in this group of knowledge, I don't see specifically the application, the real world, the problem. So there are a lot of tools, a lot of techniques and tools, but then I think there's a lot of difficulty in identify the problems or modeling the problems. So what, how are you dealing with that thinking, those set of subjects?
So that's why this is the short thing that if you look at the website, we go into more details about what you just discussed here. So here we are very, we take advantage of what is there, right? So, for example, the industrial applications that we've dealt with, and Alvaro and Marta can complement with the oil and gas industry, because it's there. The scientific applications, which are also industrial or in geology. With PlantNet, it's plant botany. And the reason is that we are in Montpellier. Montpellier is probably in the top 5 cities in the world for environmental science. There's a strong concentration of research organization to deal with global warming, plants, etc. So we are really exploiting the connections with the people who have real problems and with whom we want to work with. But remember the virtual cycle. Without, so we cannot address today, well, this is really an open issue, but general challenges which would be applicable to any kind of application. It's very, very different. Even in scientific applications, for example, we work biology, they will use a lot of tree data structures or whatever. In astronomy, they will use matrices. All this will be quite different. Alvaro, Marta, you may want to complement.
And one thing that we notice is that there are many apps that run on the cell phone, run on the laptop, and then when you move to a big problem, a real problem doesn't work. So we try to, our research has been always into addressing big problems. And we have to take care of many other issues that other tools doesn't work. They get very good papers, but they don't work. So you're right. We need to have focus on an application, on a real problem, and deal with those challenges.
And it's really also there's something well that you exploited very well in the fact that Inria-Brasil, for example, there's not much money. Inria gives money every year, which was good, but it's not much money just to travel and so on. But because of the collaborations and so on, we have contracts, right? So we get a lot of money to pay engineers, to pay, for example, with PromptNet, I think this year we have 3 European projects because it's not just an application to make fun and to know what is a plant. It's a tool for biodiversity studies and so on. So working with real applications also bring the money and the power to do bigger things and to build big software. So that's one thing that was done, especially with Martha's team, that I mentioned Problect, but there are many other systems which are very, very famous, right? With Vitor, for example. So that's also important because the people who worked on it, the master students and PhD students, they also learned something and they contributed to an artifact. And that's very rewarding for you, right?
Can I add something? I understood. There's one you want?
No.
Daniel is, I don't know, Daniel, do we have to finish or?
At some point, yes.
What would be very nice is to have also questions from the young people. Don't be shy, you can speak.
Anybody has questions?
Pode falar português, pode falar
Pode
francês.
perguntar em português.
Perguntas da plateia. Quem que pode fazer uma pergunta aí na frente? Tem um aluno que pode fazer pergunta.
Vous pouvez parler français. Non? Don't be shy.
Pergunta aí. Português mesmo. Pode ser em português. Pode perguntar que ninguém morde.
But anyway, maybe all this discussion might be high level for you, but I'm sure it will stay somewhere and it will work very well. Well, when I teach in France to engineers, because usually people who come to teach, they will teach them Postgres. Well, I do teach PostgreSQL or Python. Okay, Python. You do this, you do that, and you get this. But you're not just machines, right? You also need to think about, based on that. For example, in the top engineering schools in France, there's a big debate. Should I go and work for an oil company that will damage the planet? But they are asking questions like this. And top school, École Polytechnique, Total was supposed to create a lab there. The students did, and the students are the future big bosses. They didn't want to, and they had to back up. So we are talking about the future. So you guys should be, you cannot be passive, right? You cannot just say, okay, I'm gonna obey and do whatever. You will make money, right? Because if you're a good programmer, you will always make money. Mm-hmm. But you can think about, what's going to be the impact of the innovation? Is it going to be useful to the world or not, and so on. So, and I don't want to say oil and gas is bad, because it's also very good, and what's the alternative. So, but this is very complicated. But at least you can think. You should start.
Última chance de perguntas?
Daniel.
Daniel.
Eu estou aqui atrás. Última chance de pergunta.
Patrick,
ele.
você pode falar um pouco das inovações ruins que você tinha comentado mais cedo?
Innovation Day?
Like bad innovations. You said that there are good innovations and
Okay.
ones.
What is a bad innovation? In fact, this is a very good question. Let's think about a hammer. Is it a good or bad innovation? Can you do good things and bad things with a hammer? Yes, right? You can take a hammer and build a house. This is good. You can take a hammer and kill you. Okay? So behind it, in order to decide whether it's good or bad, you need time to see, for example, it's a big debate in France, nuclear power. Is it good or bad? So it depends, but right now it's really bad because we don't know how to deal with the waste. But if a solution comes in the next 50 years to solve the, all the waste, the radioactivity, which is under the hood, then everybody will say it was a good innovation. So there is time, okay? But there is also the political usage. Like, for example, AI, this is a big issue today. AI can do very good things, can help people and so on, but can be also used against people, right? And data science as well. In fact, when I was a PhD student, I had a debate with I had a colleague from Canada who was very an activist and he said, well, databases are for dictators and to control people and so on. And then I was a bit shocked, and then I came up with showing what the advantage of the database in the medical context, how good it was, to keep track of the people, to do these epidemiological studies and so on. So of course, you can use a database to save people's lives, or you can use a database to control people, and then it becomes political. But it's true that any political system which likes to control people will use all the technology. Okay? So this question of good or bad is kind of. But what's important for me is to answer the question. I would not say AI is bad per se, but AI, machine learning in particular, is biased because it is based on the data. So you have this beauty contest problem that right? There was a beauty contest with an AI, right? But all the images were from people, white collar, mostly white collar people. So the AI was biased towards white people. Okay, so it's just a matter of the data, right? And for example, in our team, we're working against biases. You can use rules. Well, there was a very interesting talk at the workshop, combining different techniques to control the AI. But there are research problems, right? But it's not the AI per se the problem. Right? The way you use it, the way you train it, and so on. Very much like with people. If you train people on an island with very few people, when they go outside, they will be lost. They will see everybody as enemies because they are not used. So, but this is a very important question. You guys should discuss because I know in France, for example, there are a lot of discussions by students themselves without us, the old, because in 10, 20 years we will not be there, but you will be there, right? So you have to build a new world. Okay, let's stop there. Thank you very much.